we're getting to the point where I had to hit the record button. So we're getting to the point where the programs are going to be getting more and more complex, right? So before we get them more and more complex, we got to make sure that we can break them apart. Like, because the Pope program's already pretty complex, and we really don't want the programs to get more complex than that. So the question is, how can we break up programs to make them less complex? Or better yet, if I'm asking you to do a bunch of little assignments, how can you break them up? And I already started showing you what you've been using a lot, which are functions. Yes? Yep, functions. So let's look at a function. What is a function? Well, we know functions from mathematics, right? A function is basically this. It's a mapping of that one set of values to another. Like, so for mathematics, you've got like, we can write a function like this. F of x is equal to x plus 1, right? This is a mathematical function. I'm not going to go anything deeper than algebra here. There's no need for this, right? But everybody kind of knows, no trick questions here, right? F of 3, that gives me what? 4, right? If I put in x, I get x plus 1 out, right? If I get, if I put in 100, it gives me 101. Nothing too scary or magical about this. Basically, what this function does is that it takes in an argument and it outputs a value. Okay. Now in programming languages, we call these arguments or parameters. There's actually a formal difference between arguments and parameters, and nobody cares except for the people who actually write the programming languages. So you'll find the terms used interchangeably a lot by people online, except for the people who are being pedantic. And typically what we say is that when we get these output values, that these are the values that get returned to the user. So for right now, we're going to just use so we're going to start by saying these programs are black boxes that just don't do anything. That just basically don't take any parameters and don't return anything. They'll just print something out. Okay. Then we're going to go, okay, let's take in a parameter but not return anything, and then we'll go into returns. The important thing to remember is that you can take in as many values as you want. Right, as an argument, we can have x, y, z, a, b, c taken in as arguments, but programming languages only ever return one thing, right? So you can only ever get one value out. Now Python likes to lie and say it can return multiple things to you, but in reality it's just returning one thing. But in Python, what I like about it is that it lies and you can actually pretend to return multiple things, even though you're returning one thing, but it looks like you're returning multiple things, so it's awesome. So functions are fantastic because they allow you to break your program up into little pieces. Now to define a function, right, we can say, we can do it like, we just use something called def. Def is short for define or define function. So, and then we can give it a name. And then we use parentheses to indicate that it's a command. So let's call this function print hello. Right? I think I've showed this to you guys already. And all this will do is that when this command is ran, it will go hello. So if I now call this print hello in my file, it's going to just print out hello when I run it, or when I call it. Now if I call it again, if I call it 3 times, I can call this 3 times, and the parentheses are how I know that this is a command, a function call, as opposed to some variable that I just created. So now what's cool about this is that you might think this is kind of useless, right? I could do that in one line. But I have 3 identical lines over here, and they do different things. So if I want to change the way all 3 of these lines work, I only have to make one change, and that's right over here. So if I change this single line over here, I get them saying hello world. If I make another change over here, where I go like for blank in range 5, for blank in range 5. So what blank in range 5 does is that basically it says the blank over here, right? Normally I put a variable called x or something over here, but a lot of times when you do a for loop, you don't need the variable. So if you put a blank there, you're just telling Python, I don't need a variable. Don't care about it. Don't create one. Just execute 5 times. Okay. But for simplicity's sake, I'll just simply go for x in range. Right? And so now each of these print hellos will print out hello 5 times, right? So, these are fairly straightforward, but really they're not. You're not going to do too much with them, right? Because they run the same way. If it doesn't take any inputs, then it's not. That's going to run the same way every single time. So typically this is useful if I create a single function called main that and I basically use that as a starting point for my code. Otherwise, it's really a lot of the times it's not too useful to do that. More useful are the kind of mathematical stuff. So I'll create what looks like your classic mathematical function here, right? Define f, right, of x, right? So here I'm taking in an argument, okay? So f of x, and I'm taking in an argument. It doesn't care what type x is. Python doesn't do any type checking. In other words, you can put x can be a string, it could be a double, it could be an integer, it doesn't care. But there are ways to make Python care, but what we'll do is that instead we'll print x plus 1. So we're just doing this up here, right? So now I'll just simply do f of x. So instead I'll go do f of 5. And it'll print out 6, right? So f of 5, it calculates x plus 1. So let's actually create a variable, x plus 1, and print out y. 6. Now, as mentioned earlier in class, right, these variables created inside of functions only exist inside of functions, right? So I pass it into here. I pass an x into here. X plus 1 is equal to y. Y has a value of 6. I print out 6. And it says y isn't defined because that y only exists inside of the function. So if I put in 100 now, it's going to print out 101. Okay? So another thing I can do is that I can change this hello statement to and give it in and give this a variable over here called num times, right? And that's pretty cool. What I can do now is I can change this variable to num times. And now if I call print hello, if I say print hello 5, it'll print hello 5 times. If I do print hello 100, it'll do it 100 times. Why is that? Well, I pass 100. So when I call print hello, it copies 100 over into num times. It copies it over into the first argument. We know that this gets copied over here because this is the first and only argument. This is the first and only argument. So obviously we're going to copy this into here. So then this is basically defining a variable for the function. Something that so for x in range 100, right? Because that's what got passed in as num times. If I were to do 50, num times is now 50 for that time. So if I do print hello 1 and print hello 7, let's do something we can count, 2. So you've got 1 print hello and 2 print hello, which makes 3 print hello. Now going back to our mathematical function, a lot of times what we don't do is that we don't print this value. Instead, what we do is that we like to get something out of the method, right? Like y over here, right? We'd like to use maybe we'd like to use y, but we can't really use it because y stops existing at the end of the function. So this is how you get something out of a function with a return statement. And you just say the value you want to return. So let's see how this works. Output is equal to. Now again, we could name this globnaz or whatever you wanted to call it. The function name, the variable name there doesn't matter. Print output. The output is So here, what I did is I took 100. It copies 100 over into here. We do 100 plus 1 stored into y, and then we return y. So what happens is that basically that when you have a return function, return statement, this suddenly turns into an expression you can that can be evaluated. It's no longer just a command that gets executed. It's also an expression that you can evaluate that turns into a value. So this will turn into a value. F of 100 will turn into a value. What value does it turn into? Well, it depends on the function. This one returns will evaluate to whatever this is plus 1. So we store it in output. Okay. Also note that basically still y doesn't exist. We copied this value out of the function. And this becomes a way you can hook different function calls into one another, which is pretty nice. So let's see. There's a couple of different things we can. So there's a bunch of other things we can do with functions. But primarily its use for right now is being able to organize our code into small miniature programs. The idea here is that with functions, we can take our program and take it apart into other things and organize them into small miniature pieces. Right? Now, I think I was talking about prime numbers last time, right? All right. So let's work on a program that prints out basically, let's call it sieve1.py. I like prime numbers because they basically bring everything that we're using together. So let's go ahead and show how we can use functions to build a program that will print out all the prime numbers from 1 to whatever number we want. Let's go with 100 right now. Okay. So let's go ahead and what? Yeah, well, there's a couple of things to the first. So what I like to do is first have I like to break this program into chunks, right? What do I need to do if I want to print out all the prime numbers from, so I want to print all, let's move this comment out. Oh, so print all primes from 1 to whatever the user input. Okay? That makes plenty of sense, right? So the first thing I need to do is let's think about this. Well, it's a user input, so the first thing I need to do is give instructions on what this program does. Get user input next, right? So I'm thinking that these things, because this is a big task, right? So I'm going to just break it down into smaller tasks. Give the user instructions, get the input from the user. So 1 is automatically prime, so I'm going to print that. And then for each of the numbers from 2 up to and including from 2 up to and including the number. Check if the number is prime. If it is, print it out. Right? That's pretty much right. See how I've just basically just simply taken this up over here, this top statement over here, and just broken it down into logical steps, right? This one's fairly big, which means that we can probably change it, we'll look at it and see what we can break it into new functions for, okay? We could make each of these a function, but we don't necessarily need to, okay? If it is, print it out. Okay, that's it. And so what we'll do is that we'll first give the instructions to our user. So print, enter a number. Print, this program will print all prime numbers up to and including that number. Or do we want to go with all prime numbers less than that number? Do you want to change what the program does and change it to all numbers less than that number? Up to and including. Okay. So let's go ahead and, if we run this now though, it's not really going to do anything because of course we've just defined a function. And we haven't called main, and we haven't called it yet. So I'm just going to call this function main down here. Okay. So now we need to get the user input. So let's call it number is equal to input. But this is going to give us a string, right? So we'll go ahead and turn this into a integer. Okay. 1 is automatically prime, so we're going to go ahead and print that. No problem. So for each of the numbers from 2 up to and including that number, check if the number is prime. If it is, print it out. So this sounds like we can break this up. Check if the number is prime sounds like its own mini program. So we'll go ahead and write a mini program that does that. Okay, so let's go ahead and write a function, as you rightly called it, called isPrime. So let me write a comment to make sure I understand what it's going to do. Checks if let's give it a number called x. Checks if x is prime or not.
Wouldn't you automatically print 2 as well, so this is prime?
Yeah, we're getting into kind of a run-up. Yeah, we'll see. We're gonna make adjustments to our program as we work on this. Okay. So so first off, let's just go ahead and assume the number is. So what I'm going to do is I'm going to assume that for the sake of moving on with this program, I'm going to assume that every number is prime, right? So you're allowed to do this. You're allowed to like give everything a dummy value just to make sure your program's working, right? Or partially working. So I'm going to say, right, and with if statements we deal with true and false statements, right? To check if it is, right? If it is, print it out. So that sounds like a Boolean statement. So I'm just going to simply say every number is prime because I want to get on with my life, even though that's not true. So, and then we can get back to that. But see how making it a function allows us to like leave it for later. So for each of the numbers from 2 up including the number. So that sounds like a for statement. So for x in range up to and including the number. So that means we want number plus 1 if we want to include that number. If is prime x. So if the number is prime, right, if this function call returns true, print x. Make sense to everybody? So if I run this, let's go ahead and see how. So save it, right? And because I want to make sure the logic that these parts work before I get into the logic of checking if stuff is prime. So I said print the numbers from 1 to 100 that are all prime. So I entered 100 and printed out 1, 0, 1, 2, 3. So in that case, I probably want to I want to start with 2. So how do I start the range at 2? Because remember, I had 1 and I printed out 1, then I printed out 0, 1, which I didn't want to do.
Range 2.
Yeah, so it's 2 up to that number. So now let's run it again, just up through 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Great. So obviously a bunch of those numbers aren't prime. Okay. So, but let's go into this function. So we're going to return true if the number is prime. So, right, now we're just in a smaller puzzle. If the number is prime, we'll return true. If it's not, I'll return false. So how do I know a number isn't prime? It's divisible by, well, just, if it's divisible by anything. If it's divisible by anything but 1 in itself. So, we'll check all the numbers from 2 up to and including itself. So for let's call it factor in range 2 to x. So from all the numbers from 2 up to x, up to but not including x, if factor. So now here we need to check basically, is x divisible by factor? So if x mod factor equals 0. So I just wrote something there. X mod factor, and I think I wrote it early. I wrote it in the video, but let me go ahead and explain it again. So if we divide x by this factor, so say that this number is prime is 10, right? So say I'm passing 10 into here, so factor starts at a 2. If 10 mod 2 equals 0, right? Well, 10 mod 2 says, okay, let's take 10, divide it by 2, and get the remainder from it. What is the remainder? 10 mod 2, the remainder is 0 because 2 cleanly divides 10. So if this number cleanly divides another number, if x is cleanly divisible by factor, then it's not a prime number. So, well, we don't want to continue. Yep, so what we're going to do here is actually use something way more useful than breaking, which is that we're going to return false. Now, when you hit a return in a function, you immediately stop what you're doing and just end the function right there. Just like a break statement immediately ends a loop. It's for that reason that we typically put returns at the end of a function. But here, since we know that the if statement is, basically is, this proves it basically that it can't be prime, right? Then we don't need to keep checking. We can just stop here, right? We don't need to keep checking to see, right? Because it's divisible by one number. If it's been divisible by a number, we don't need to check if it's divisible by more than 1. So now let's go ahead and run this. So let's go ahead and print all the prime numbers from 1 to 10. So 1, 2, 3, 5, 7. So those are all prime numbers. So now let's run this program again. Let's do 1,000. So those are all the prime numbers from 1 to 1,000. Allegedly. What is not a prime number? Is it? Let's see. Is 1 prime? A natural number greater than 1. So. Is 1 prime? Why is 1 not a prime number? Prime neither a prime or composite. 1 is not. Why is it not? Because that's because the right? Because that's exactly right. Because prime numbers need to have 2 factors, and 1 has only 1. So that's easy enough to get rid of. So 1 is not prime. So, which means that we need to do, which is, Now, believe it or not, that kind of was deliberate on my part, because now it leads to interest. So now that's fine. But now what if I do this? If I do 1, doesn't do anything. Good, right? We don't want anything at that point. What if I do negative 100 or negative 1,000? It's not going to do anything because we take this and we go from 2 to negative 1,000, right? So nice. So let's go ahead and do. We don't need to check. The for loop actually just takes care of it for us, right? I tried putting in a negative number, and it just doesn't do anything, which is correct. Right. Oh, we could yell at the user with an if statement. So now this program will eventually slow down because it takes longer and longer to calculate prime numbers. But it doesn't slow down much slower than it takes to print in idle. So, but this is a fairly non-trivial task. So we'll resume doing these kind of printout statements for here, and I'll give you plenty of. I'll post a homework while you guys are working on the current assignment that goes over just basic functions. They're not gonna do anything other than be small programs again. It's going to be exercises for loops, then we'll get into exercises for functions. The most you have to do is organize your program into separate functions rather than separate files. So let's go ahead and take with the remaining time in the class to work on the Pope program. For those of you who are done with it, I'll post the next homework assignment